Hi there, this is going to be a walkthrough of an entire 10 question paper aimed at the typical Nursing Year 2 Mental Health Branch numeracy exam. Now, first thing we need to think about is for each question we need to ensure we add the correct unit or label. Here are some common units and their accepted abbreviations. Ensure that if you are going to abbreviate your units that you use these abbreviations and no other. The paper itself is typically 30 minutes unless you're allowed a little bit extra, and as I've said, there are 10 questions on the paper. Important to notice that each question only receives 1 mark. There's no partial marks or method marks available, so if you make a mistake, for example by including the wrong or incomplete units, you will lose the whole mark. So this is why right out the gate I'm banging on about units. So let's dive in. Question 1. If a person weighs 90.5 kilograms, what dosage in grams of a drug must be given if the prescribing instructions state 20 milligram per kilogram of body weight? It sounds a little complicated, but the key here is this phrase per kilogram body weight. That tells us it is a weight dependent question. So whenever you see that phrase per kilogram, it not only tells you it's a weight dependent question, but it also prompts you to multiply by the weight. So we'll take the 20 milligram and multiply it by the 90.5 kilograms. Now you'll notice that I've highlighted more overtly the milligram rather than the kilogram, because the kilogram, the weight of the patient, is simply a multiplier. It's the key weight of the drug, in this case milligrams, that will be retained. So take my calculator, do 20 times 90.5 and I get 1810 milligrams, and it's the milligrams that I'm retaining here, not the kilograms. Now we're not quite finished, because the question clearly said in boldface what dosage in grams. So we need to do one more step. We need to convert that milligrams into grams, and for that we need to think about whether we multiply or divide by 1000. Now there's a very nice little staircase diagram that we use. A lot of students learn this off by heart and jot it down on their answer paper. Now we've decided we need to convert milligrams to grams, and according to the staircase, milligrams to grams will be going upstairs, which tells me to divide by 1000. So I take that 1810, divide it by 1000 again on the calculator, and I get 1.81. So into my answer box I put 1.81. Mustn't forget the units. Now the units will now be grams. We've converted that milligrams to grams, so there it is, and that's the question complete. Okay, on to question 2. You're organising a trip for 16 clients to go swimming. Tickets are £3.50 each. If one member of staff must accompany every 4 clients, what is the total cost for the swimming trip? This looks pretty straightforward. We're just going to multiply by £3.50 however many people are going swimming. But of course we need to find out in total how many will be going swimming before we can multiply by the £3.50. Well, we've got the number of clients written clearly, that is 16. But then he says if one member of staff must accompany every 4 clients. So to find out how many staff, I must divide that 16 by 4, which is 4. So there will be 4 members of staff. So there will be in total 20 people going swimming. So now we're ready to do step 2, the final step, which is to work out the total cost, which is the £3.50 times 20. So in the calculator I'll just do 3.50 times 20. That gives me 70. Pop that into the answer box. Now what are the units here? Now clearly the units are pounds. We're talking about money here, so it's just £70. I could have written that as 70.00 pounds, but don't just write 70.0. We all know that money is either written in whole numbers, or if there are going to be decimals, there's always 2 decimal places. Either way your answer will be considered correct. And we're done. Question 3. A patient is prescribed an oral suspension 250 milligrams. The label on the bottle states that there are 0.5 grams in 2.5 millilitres. in millilitres state how much syrup would be given. Now this is a liquid dose question, and for a liquid dose or indeed tablet dose there is a single formula that we use, and that is commonly this one: what you want over what you've got times what it's in. Now whilst I'm a big fan of formula, I appreciate that this one could easily be mixed up if you're in an exam situation. You might just get a little muddled. So I need you to think and understand about what each term means. Now what you want means what do you want to give the patient, and what you've got means what have you got in stock, and then what it's in is the volume. So I often think of it as patient over stock. More overtly, I think of this idea of the patient comes first, that old adage which alerts me as to what number I want to write down first. Now the patient is prescribed 250 milligrams, so I'm going to unpack this question using the formula and write down first 250 milligrams. Then I put it over the stock, which is 0.5, and the what it's in 2.5 millilitres. So you can see this first step is me simply using the formula to faithfully extract and write down the right numbers and units. But we're not ready to take our calculator out yet. There's one thing we must always do with the dosage question, be it a tablet dose or, as in this case, a liquid dose. And that is, we must look at the units in the fraction and ensure that they are the same. Now as these units are not the same, we need to make them the same by either making them both milligrams or both grams. It's entirely our choice. So what I'm going to do is I'm going to choose to make the bottom one, the 0.5 grams, into milligrams. So let's remind ourselves how to do this. Thinking of the diagram again, I want to go grams to milligrams, which is now downstairs, so therefore I'll be timesing by 1000. I'll be multiplying the 0.5 by 1000. So calculator out, 0.5 times 1000 is 500. So now I can rewrite that formula as 250 milligrams, that stayed the same, over 500 milligrams times 2.5 millilitres. And now we can see that as our units are the same, top and bottom, we're now ready to calculate our final answer. So 250 divided by 500 times 2.5. What I've done there is I've done top divide by bottom. That's how you always put a fraction into a calculator. What does that come out to be? That comes out to be 1.25. And what are the units? Well, the units are going to be millilitres, so let's write those down. And in case you're wondering what's happened to these milligrams, in a very real sense, because they are the same, they've actually cancelled out, leaving only millilitres as our final answer, which is quite sensible and logical because this is, after all, a liquid dose question. And there we have it. Question 4. The dietitian has recommended that your patient, who weighs 55 kilograms, starts a weight gain program. On this, they should gain 0.8 kilograms per week. After 8 weeks, what should their weight be in kilograms if they follow the program successfully? Now there's quite a lot going on here, so let's break it down into steps. Step 1, I want to work out the weight gain. Now this told us was 0.8 kilograms per week. Therefore, I will multiply 0.8 kilograms by 8. Again, the kilograms are what's being retained. Here you'll see that the weeks hasn't been highlighted because that is just a multiplier. It's the kilograms that is being multiplied and will be retained. So the calculator tells us that 0.8 times 8 is 6.4. So the weight gain is 6.4 kilograms after those 8 weeks. Now step 2 will be to work out their new weight. As this was a weight gain, we take their original weight, 55 kilograms, we add the 6.4 kilograms. So 55 plus 6.4 is 61.4 kilograms. So pop that into the answer box and don't forget the units. In each occasion, it's always important to ensure that you don't move on to the next question until the units have been input into the answer. Okay, on to the next question. Question 5. A patient is prescribed 0.3 grams of a drug. you only have tablets of strength 0.15 grams, how many tablets would you give? Now just pause the video in a moment and ask yourself, what do you think the answer is? Okay, now you might have intuitively thought the answer was something like 5 tablets, and when I take this on a class, that is an answer that many people intuitively come out with. But actually that's not the right answer. Let's unpack this. Now it's a dosage question, so I can use the same dosage formula as I used before, whereas before it was for a liquid dose, now it's for a tablet dose. And again, as before, I think about the patient coming first. So let's unpack the question using the formula and faithfully recording all the units. So I've got 0.3 grams is what I want to give the patient, 0.15 grams is what I've got in stock, and that's times 1 tablet. Now on this occasion we can see that initially we are happy that we have the same units top and bottom of that fraction, and therefore there is no need to do any conversions. So I can get the calculator out and do 0.3 divide by 0.15 times by 1, and you'll see that the answer comes out to be 2. The answer is only 2, and what are the units? Tablets. Many people are a little surprised initially when they see this answer because it doesn't feel right, but that's because we're not comparing the numbers 3 and 15, we're comparing the numbers 0.3 and 0.15. Well, those two numbers are expressed to different numbers of decimal places. If I'd written the 0.3 as 0.30, then you could have seen it was looking like 30 divided by 15, and that's where the 2 comes from. This is a good cautionary tale as to why you should always check your answers with a calculator, even when you think the answer appears obvious. Now that unit, tablets, is of course not really a unit as such, but it is more of a label. As I said right at the beginning, it's important that every answer has a unit or a label in order to give the answer, the numerical answer, a context. Okay, on to the next question. Question 6. A family receives benefits totaling £380 per week. Following a government announcement, these are to be decreased by 0.8%. How much money will this family now receive? Again, it's going to require 2 steps. The first step is to work out the change in income. Now, the change in income, we need to work out 0.8% of £380. I turn that 0.8% into a fraction, 0.8 over 100, and that word of becomes a times. So the calculation we must perform with the calculator is 0.8 over 100 times 380, and that is 0.8 divide 100 times 380 gives us 3.04, and of course it's £3.04 written with the units. That's our change. The final step is to work out the new income. I always go back to the question and work out, have they given us an increase or a decrease? In this case it was a decrease, so I must take that away, take that £3.04 away from £380. So 380 take away 3.04 equals 376.96. Pop that into the answer box, and my units, my label, is in this case the pound sign. Here I had to give the decimals. Always be careful if the calculator gives 1 decimal place, because you would then have to put an extra 0 on. Here it didn't, it gave us 2 decimal places, so we recorded faithfully those 2 decimals. We are not looking to round up any of these questions unless they tell us to do so. And we're done with that question. Question 7. Look at the fluid balance chart. What is the difference in millilitres between the fluid input and fluid output between 1345 and 2000? Well, here's the fluid balance chart. Now you probably won't get one as tricky as this, because here they're not asking you to use all of the values, but they've limited it to between the times of 1:45 in normal time and 8 o'clock at night. So I've just highlighted the region we're looking at, but do read the question carefully in case they do something like this in the exam. So we need to work out the total fluid input and then the total fluid output, and then take one from the other. Now the total fluid input is that top line, So I'll simply add 130 at 240 at 220 at 190, and on the calculator that comes to 780 millilitres. And then step 2 is to find the total fluid output. Well, that's this bottom line, 245 plus 190 plus 210 plus 220, and that gives 865. And the third and final step is to work out the fluid balance. Now the fluid balance formula is always input minus output. So I'll just put on the calculator 780 minus 865, and that equals negative 85 millilitres. Now in your exam, because they are only asking for the difference in millilitres, it is likely that they will not be worried about this sign, whether it's a negative or a positive. I'm only including it here because when you are doing it as a nurse, you need to record whether their fluid balance is positive or negative. So I'm just being a little bit extra thorough in this case. Either way, the fluid balance is input minus output, and it's the 85 that's an important number for your calculation. Question number 8. An awareness event for service users is being organised. The total cost is £1,560 to arrange. The host trust is prepared to cover 1/3 of the cost. The remaining money has to be found by selling tickets at £20 each. How many tickets need to be sold in order to cover the costs? There are 3 steps to this. First step should be, let's calculate the trust contribution. Now we've been told the trust is going to cover 1/3 of the cost of that event. So I need to find 1/3 of 1,560. Now I could write it as 1/3 times 1,560, using that idea in an earlier question of the word of becoming a times. That would be 1 divide 3 times 1560. But many people just see this as being simply to find 1/3 of a number, divide it by 3, and that is perfectly okay to do. Either way, the answer comes out to be £520. I would suggest in your case go whichever seems most logical. Don't overcomplicate the question if you're a little bit shaky with it. So now that we've worked out that the trust will contribute £520, we need to work out how much is left that still needs to be raised. So step 2 will be to take that 520 from 1560. And again, the calculator tells us that the answer is £1,040, 1040. So we're now ready for our third and final step. We know we're going to raise this amount, £1,040, by selling the tickets at £20 each. So my third and final step is to divide that remainder number, that 1040, by the 20. 1040 divide 20 gives 52. Now a useful check here is that this final answer should come out to be an exact whole number, because after all it's how many tickets need to be sold. If you find that you have a decimal here, it's very likely you've made a mistake early on, and you would go back and check. It will probably be in step 1 that the mistake has been made. So let's record that answer, 52. Now what are our units? It's no longer pounds but tickets, and notice how in the question they very thoughtfully gave us that word tickets in boldface. But again, if you forget to put that label, in this case the word ticket, you will lose the mark and therefore not get this answer right. Okay, question 8 all done. On to question 9. A patient who has noticed a decrease in weight over the last few weeks. You know from your records on admission that her weight was 60 kilograms. The patient's weight is now 55.2 kilograms. What is the percentage decrease in his weight? I like the way the gender has changed partway through. Okay, step 1. Let's calculate the change in that person's weight. So that is simply a subtraction. 60 take away 55.2, well that is 4.8 kilograms. So we have got the change in weight. In this case it was a weight loss. Step 2, and this is very important, we must compare that change in weight with the original weight, and this is where some people often go wrong. So I'm comparing 4.8 kilograms with 60 kilograms, not with their new weight, but with 60 kilograms. So here's a useful formula. The change in weight over the original weight, and then I've done this extra bit times 100 in order to make it into a percent. So let's unpack that question using the formula 4.8 over 60, the original weight, times 100. Now you now know how to do this in a calculator. It will be 4.8 divided by 60 times 100, and the answer comes out to be 8. If the answer is a decimal, so long as it's a well-behaved decimal like 8.1 or 3.6, then you'll record that. It's only if the decimal goes on, as it were, forever, that you might question whether you have interpreted the question correctly. If it does look like an unlikely answer or a badly behaved decimal, then the chances are you've divided by the wrong number. So the answer is 8. What are the units? We'll go back to the question. It said what is the percentage decrease in weight, so it's 8%. I don't need to put minuses or plus. It is an 8% decrease in weight. It is a sensible number. Okay, we're done with that question. On to the final question. Question 10. A medication is prescribed as 84 milligrams daily to be given in 3 equally divided doses. State in grams the amount of medication needed for each individual dose. Now by now we're quite used to the fact that most questions have to be carried out in several steps, and this is no exception. Step 1. I want to calculate the amount per dose. Now there are going to be 3 doses that patient will receive in the day, so the first thing I must do is divide that 84 milligrams by 3. I've highlighted the milligrams because this first step will still retain milligrams. Now on the calculator, 84 divided by 3 is 28. So it'll be 28 milligrams per dose. And you can always check that just by adding 28 together 3 times, and indeed you do get 84. Now we're not quite finished yet because we want the answer in grams, so we have to do a conversion. Now this is the third time we have seen a conversion element in this paper. We want to convert that 28 milligrams into grams. So let's remind ourselves of our little diagram. You can see how useful it would have been to jot this down at the beginning of the exam. Milligrams to grams, we're going up the stairs, so we're dividing by 1,000. So 28 divided by 1,000 is 0.028. So pop that into the answer box. What will the units be? Well, of course, we've converted finally into grams as instructed, so it'll just be grams. And there we have it. There is the paper done, all 10 questions. I would not advise you on a first pass of this question to do anything other than use a calculator for every calculational step. You want to maximise the efficiency by which you finish this paper, so you crucially have check-in time. Which leads me on to a few final thoughts. If you have time at the end, and so long as you've carried out a few practice papers, you should be efficient enough to have created time at the end for check-in. The first thing you would do is go back to any questions that you felt that you struggled on or didn't feel right at the time. Also, for every single question, ensure that there are units or labels recorded in each answer box. As I've said more than once, failure to do this will instantly lose you the full mark for that question. And then, does each answer seem reasonable? Does each answer seem logical, or does it seem completely unrealistic? If it does seem unrealistic, for example, you were given someone 28 tablets, or you had to find 5,000 tickets, chances are there's been a mistake made in your calculation. The questions set up are designed to be realistic. And finally, because you've been using a calculator, we all know it's easy just to press the wrong button by mistake. I think if you have the time, it is always worth rechecking your actual calculations on the calculator just to make sure that no slight unforced errors have been made. And that's the end. Thank you very much for your attention.